Right, for number 1, was this mapping a function?
Yes.
Yes. Number 2, we need to simplify the expression. Combine your like terms. Negative 15 plus 2 would give us negative 13k. Negative 1 plus 12 would give us positive 11. Yes, so the Dutch speaker. Yes. For number 3, you had to find the domain. Because they gave you ordered pairs, you had to list them least to greatest. What were those numbers least to greatest? So you guys can say them out loud.
Negative 1, 0, 2, 3, 5.
To make sure those are least to greatest. Number 4, you needed to combine like terms, so you needed to distribute before you could do that. So negative 12x minus 6 minus 2x plus 6 plus 15x minus 20. Combine all of your like terms. So we have negative 12, negative 2, positive 15. Negative 12 minus 2 is negative 14. Negative 14 plus 15 is positive 1x. Negative 6 and positive 6 cancel each other out, become 0, so you're just left with negative 20. So x minus 20 was that final answer. And then for your perimeter, you could have either made sure that you had, I'm sorry, that was the wrong one. These on all 4 sides and added them up like that. You could have used that formula I gave you, 2 times 2y plus 2 times 3y minus 5, distributed and combined my terms. So this would give us 4y plus 6y minus 10. Combine your y's to get 10y minus 10. If we knew what the value of y was, we could actually find the perimeter, but it didn't ask us to do all of that. And we don't know what y is. Yeah, thank you.
I think you said the another way you could do it was length times 2 was times 2, right?
Yeah, that's what we did here. I think I just
negative
switched
5
them.
makes negative 5 be 10, positive 10.
You're multiplying this by 2, not this by itself 2 times. So you did negative 5 times negative 5, not negative 5 times positive. Right. Any other questions on those? Before we start our new notes for today, there's a couple things I wanted to talk to you about. One, besides the test we just took and the Khan Academies that we're doing on Friday, nothing else is going in grade-wise unless you retest or go back and redo missing Khan Academies or do those to bring them up. Those were the last grades that are going to go in this marking period. Everything in this unit is going to be put in the next marking period. So when you look for these grades, they won't be in marking period 1, they'll be in marking period 2. What's the text for this unit? Look on your gold sheet. But that's also why when I put them up here, they're star, because I pushed them back because technically we're not supposed to be testing during the week of homecoming. But Dr. Healy changed some of that. So instead of starting unit 4 and having those days, we might push the test up to the 20th and the 21st. So, but it also depends on how much we get through. So we'll cross that bridge when we get closer to that. I can't say that for certain today. Plus, anything could happen between now and then. So remember, these are always tentative. Things could change. So just be on the lookout. I'll remind him in class if something changes. I'll also change the dates on Canvas if something changes. So look at both of those things if that test date does change. Also, if you need to retest Unit 1 or Unit 2, so the one we just took, come before or after school so you can start that retake process. You'll need to do test corrections, make sure you're not missing any work. Depending on your grade, you may have to do additional work, and then you can retest. But besides retest grades of those tests and you redoing Khan Academy grades to bring those up, your grade is not changing from what it is right now, unless those things happen. Okay? So if you want your grade to increase, you need to do retests or go back and redo Khan Academies. Keep that in mind. Any questions on any of what I just said? So our next unit, we are going to be talking about solving equations. Some of this may be review to you, and that's great. Some of it may be new to you. That's fine as well. So the first part of this, and this should really stay. I'm going to ask, and then I'm just going to get your opinion, and then I'll form an actual answer to this. So if I said, what is the solution, what comes to mind? Let's do hands. Here.
A way of answering something.
A way of answering something. So I'm just going to write that down. That's not like your actual answer here.
Oh, we just wrote the answer.
You're going to do that. So you don't have to write this part. I'm just jotting what you guys are thinking down. Anyone else have something different come to mind?
The answer to a problem.
Answer to a problem, okay.
The total of the problem.
And
Total.
the total of a problem. Total means adding though, so we would have to be adding. So can we reword that so it's not just for adding? Jesse?
Problem.
What did you say?
Or
I just didn't hear what you said. Right, so we're trying to define that.
So we don't add the let it work into
Yeah, I'm not gonna put the solution is the solution.
the answer.
Right, so yeah, solution is an answer. I'm gonna expand that just a little bit. I'm gonna say a solution is an answer to an equation that makes it true. An answer to an equation that makes it true. And what that means is if we solve for something, we get an answer. If we were to put that answer back in, we could simplify it and see, does it equal what it says it equals? If it does, it makes the statement or the equation true. If it doesn't, then it's not a solution. So we're going to test out some of these to see if these are solutions or not. Anyone still need this part before I scroll down? So for number 1, it's asking, is 5 a solution for this? So what we're going to do is take 5 and put it in for x, kind of like when we were evaluating. So we have 13 times 5 minus 7 equals 28. And we're going to simplify this and see, is this true or not? Are you okay? If you need to step out, go ahead. 13 times 5 gives us what? 65. 65 minus 7 gives us what? 58. So this is a true statement because it equals the same thing. Yes.
You also do it where you do like 13x minus 7 equals 85 and then just solve it algebraically.
58, but
What did I say? Sorry.
you said 85, but it's okay. Yes, that would be more if we weren't given this,
Okay.
and we would solve for it. So we are going to get to that. We just haven't gotten there yet. Right? We're going to try number 2. Now, if positive 5 was a solution, negative 5 most likely won't be a solution, but we're going to test it anyway. Same thing, put negative 5 in for x. So this now is negative 65. Negative 65 minus 7 gives us what? Negative 72. Is this a true statement? Do these equal one another? No. So this is not a solution. So this is a good way to check yourself. After we solve an equation, you get an answer, put it back in, see does this work or does this not. If it works, you did this right, that's your answer. If it doesn't work, something's wrong because the answer you got does not work. Could be that you put in a negative by accident, you forgot a negative by accident, anything. Right? I want you guys to try 3 and 4, and I think I wrote in the X on you guys, and this is in the wrong place. And I think you guys it says 3x. Okay, so I want you guys to try 3 and 4. I'll give you 2 minutes to do those 2, and then we'll come back and we'll talk about them. Number 3, did we get that this was or was not a solution? Was not. Anyone need to see this one worked out? So 3 times negative 2 plus 4
Oh,
would be negative 1 equals, this would become negative 6. Negative 6 plus 4 is negative 2. These two things do not equal one another.
yeah, I thought the x was negative. That was one.
Got it. So yeah, sometimes your equation switches. I don't remember.
But I got the right answer.
Okay. And then was this a solution or was this not a solution?
It was.
Should have been it was. Anyone need to see this one? So for this one, put in negative 34. Negative 34 divided by 2 is negative 17. Negative 17 plus 5 is negative 12. Questions on those? Yeah. We could also do that, except we can't put the equal sign in with that. But you could put this sign in, sure, and see if it works. Yep. Right. Go on to the next page. Now, when we are solving equations, we're using these properties of equality to do something to both sides. That's the property of equality part. We have to do it to both sides so it stays balanced. So addition property of equality, we're adding to both sides. Subtraction property of equality, subtracting to both sides. Multiplication, multiply, divide. No. Distributive property is not something we do to both sides. It's usually, it can be on both sides. Most of the time it's on one, but it's something that just makes it more equal, more balanced. So these are solved for us already. We're just looking at what did they do to get to the next step. So it's a little confusing as you're trying to move down. This first one is given, because that's your original problem. Then in the next one, you're looking at what changed from here to here, and that's the step you write. So in number one, what did they do here? So we're just going to put they distributed. So in number two, we would put distributive property. And then we're looking at in step two to step three, what did they do to get here?
They added on both sides.
So this 18 is gone, and the only way to get rid of these things is to do the opposite. So this was a minus, so they had to add 18 to both sides. So that would be your addition property of equality. I'm just going to put POE for short, because I don't have space to write all that. And then from step 3 to step 4, what happened? They divided both sides by 2.
Division property of equality.
Correct. Do you have any questions on that, Javier?
The number 2, do you write distributed property of equality or just property?
Just property. So annoying. Alright, we're going to skip number 2 because I'm going to let you guys try that in a little bit. Go down to number 3. Again, the first one is given because that's your original equation. And then we're looking at from step 1 to step 2, what did they do? So here they multiplied on both sides to get rid of this 2. That's your multiplicative inverse happening so that this becomes 1. But because they multiplied by 2, they also have to multiply by 2 here, which is how they got that 14. So that would be your multiplicative property of equality, or multiply. Then from step 2 to step 3, what did they do? So they took this one, it's no longer there, they added it to the other side because they're doing the opposite. And then from step 3 to step 4. So you divide it. By what? Yes, on both sides. The 5s are looking like days, but they are 5s. I'm going to give you a minute to 2 minutes to work through number 3, talk with the people at your table, compare your answers, and we'll come back and check it. Yes, that is what I meant, number 3. Okay, so for this one, what did they do from step 1 to step 2? They subtracted, and what did they subtract? 10 on both sides. And then in step 2, from step 2 to step 3, what did they do there? They multiplied the -3 on both sides. So subtract and then multiply should have been your answers there. Any questions on that? Move on to the next page. So this question is kind of like the first one, but now we're going to kind of include what we talked about before. To solve an equation, we have to find a solution that makes the equation true. So part of that sentence is a little redundant because the definition of the solution is to make it true, or that makes it true, but as we're solving these equations, and we could expand this definition as well.
Does to find the answer that makes the problem true work?
We want to use solution in the definition. I was going to say we could also include use inverse operations to find a solution that makes the equation true. That would expand the definition. But for those inverse operations, think about those as opposites. So inverse, opposites, kind of mean the same thing. What would the inverse or opposite of addition be? Subtraction. So I'm just going to draw a line that connects these two. You can do the same, or you can write out subtraction, either or. The opposite of division? Multiplication. The opposite of squaring something? Cube. So in this case, it'd be taking the square root of something. So think about it like this. 2 squared is what?
4.
4. The square root of 4 is what?
2.
They undo each other. So then the only two left, cube and cube root, undo each other. So if I said 2 to the 3rd power, that's 8. The cube root of 8 is 2. They undo each other. So these are really if you get stuck. If you're not sure, how would I start this? You can refer back here. Distribute, if it has parentheses, sometimes that won't always be the case. Sometimes there's ways around that. Combine like terms on the same side if you have multiple. Move the constant by adding or subtracting, kind of like what we were doing before, and get the variable by itself, by multiplying or dividing. So we're going to go through a few of these together, and then I'm going to let you test them on your own. So our goal is to get the variable by itself. So for number 1, we got to get x by itself we need to get rid of the negative 2 and get rid of the 3. We're going to hold off on getting rid of the 3 until the end, since that's directly connected to x. Peggy?
Positive 2, negative 2.
So we're going to add 2 on both sides. Remember, we are always doing these to both sides. And then how would I get x by itself?
Divide by 3.
Divide both sides by 3. So x would give us positive 2. But I want to make sure that this works. So I'm going to take this 2 and I'm going to check it. I'm going to put it back in and see, is this my actual solution or not? So kind of next to it, I'm going to do that. 3 times 2 minus 2 equals 4. 3 times 2 is 6. 6 minus 2 is 4. 4 equals 4. That works. So after each time you solve an equation, you should also be checking it. Make sure it works. For number 2, we need to get rid of the 4 and the 2. We're going to hold off on getting rid of the 4 first. So how would we get rid of the 2? Subtract it. So when we subtract it, the 2 go away. Now we need to get rid of the 4 that it's dividing by. By doing what?
Multiply.
You guys can say that out loud.
Multiply by the reciprocal.
Which would be what?
4 over 1.
Or just 4. But what I do to one side, I have to do to the other, so that would become 32. And then I want to go back and make sure that this is my actual solution. I'm going to check it. 10 equals 32 over 4 plus 2. 32 over 4 is 8. 8 plus 2 is 10. So that works. Do we have any questions on those two so far? We're going to go to number 3. Number 3 is very similar to number 1. It just has that fraction, but don't let that throw you off. We're doing kind of the same thing.
I just saw number 2.
On which
I
part?
was writing the one in green.
So this is just the check method. Right? This is putting it back in to make sure it works. You
Yes,
understand how we
which one did you
found
do first?
this one?
No, the queen, the top one and the bottom.
Oh. This, then this, then this.
Is that a 4 or a 1?
Right here?
Yeah.
That's a 4.
Okay.
Okay. May hit some more. Any other questions on 1 or 2? For number 3, we need to get P by itself.
Plus 2 times plus 1.
So we're going to do that first. I believe that's correct, yep. And then to get P by itself, yes. But if you didn't remember that, you could divide by the fraction first. When you divide it by your fraction in the calculator, you're going to get a bigger number than what you started with. And the only way that would happen is if you instead, because what the calculator is doing when you do that is multiplying by the split version. So multiply by that reciprocal of the fraction so that these cancel become 1. What would P equal? Because so if that's confusing, you could think about it like, don't write this down. 2/3 is multiplying by P, so normally anything multiplying you would divide it. And then also do that to the other side. But here we have a fraction, we're dividing it by a fraction. Or we have a fraction within a fraction. And then same thing here. So if I were to put that in my calculator, which I don't have up. We did this yesterday. But I could put this fraction within a fraction by doing alpha y equals, going to my denominator, and doing it again. And then putting this all in. But when I divide this fraction, I end up with a bigger number than I started with. And the only reason that is because really I'm multiplying by the reciprocal. That's what the calculator is really doing.
Um,
Can we go back? Yeah.
that's times right 140 times 3, 2.
Yes.
Okay.
So you could really do either or, but I would prefer that you just multiply by the reciprocal. It'd be easier than trying to put in double fractions. And then we're going to check and make sure this works. So put 210 back into P. Like someone asked earlier, could you just put this back in to the calculator? Sure. So I could put in alpha y equals 2/3 times your 210 and subtract 25. And that would give me the 115 that the other side equaled. So that would be a faster check method. Later, once we've gone through the next set of those, after we finish this packet, I'll show you some ways you can check yourself on a calculator and Desmos. Not today. We're going to skip number 4, move on to number 5. Number 5 has parentheses. How do you think we're going to start this? Yeah. So if we distribute, we would get -6. You guys have x. Yeah. Plus 3. And now I have to get x by itself. How would I do that? Would I do that first?
No.
And I wouldn't be adding the 6 because it's right next to x.
Minus
Yes. So we're going to get rid of this 3 first, get everything that's not directly connected to the variable first. And then what? Not add. What are negative 6 and x doing to each other? So anytime two things are next to one another, what are they doing?
It's multiplication, but then you change it.
Right. So, and I didn't do this before, but they don't have the parentheses like we normally put or the dot, but there's like an invisible set of parentheses or a dot there. So we just have to remember that these are always multiplying. So to undo that, we would divide. Now, we'll do the check here in a minute. Where you have some open space, write this problem again. We're going to do it again, but a different way. So if the method I'm about to show you like, you can use that. However, the only time you can use this method is if this number outside of the parentheses is a factor of this. So like I can divide this and this goes into this without becoming a fraction or decimal. If that is not the case, we cannot use this method. So for this, because I can divide 15 by negative 3 and get a whole number, that's what I'm going to do, divide both sides by negative 3. This isn't breaking any like math rules because I did it to both sides. So this becomes negative 5. This really becomes 1. Or the negative 3's cancel, so I really don't even need that part. I could have just skipped right to that last step without putting the parentheses. And then I can still solve for x. It would just be different than how I did it before. So we would add 1 to the other side. And divide both sides by 2. We would still get the same answer, just we got it a different way. Do we have any questions on that second method? X minus 1. So when we put that in to check it, we do get 15. So I'm just going to write off to the side 15 equals 15, and then this works. Right, number 6, I'm going to show you guys how to do it 2 different ways. If you get lost or miss a step, it is on this backboard as well. But I would say follow with me first, and then it is back there if you also need it. So the first way we do this is going to deal with the fractions. The second way we do this is going to get rid of the fractions. So in order to deal with the fractions, if I wanted to combine these 2 fractions, the only way I could do that is if I got common denominators, which right now they do not have. So I would need to think about a number that both of these go into, or a multiple that these two share. 6. So to make these both 6, I would need to, for this first fraction, multiply this by 2. But what I do to one part of the fraction, I have to do to the other part. So I also have to multiply the top by 2. For the other side, to get this to be 6, I have to multiply it by 3. And then what I do to one piece of the fraction, I have to do to the other. So they're kind of like equations in a way, because you have to do it to both parts. That would become 2 times 2 gives us 4x over 6. This becomes 3x over 6. Notice that I did not multiply 2 and 3 to the other side because I'm just dealing with the fractions. I'm not dealing with the entire equation as a whole. Now that I have common denominators, I can combine these as a fraction. And because this is now in one fraction, I can combine my like terms. So this would become 7x over 6. From there, I could rewrite this so that the x is next to it if that makes it look better for you. And then multiply this by the reciprocal. These would cancel, become just x. 7 times 6 is 42. 42 divided by 7 is 6. So our final answer would be 6. Do you have any questions on that process? Yes, Tony. At the beginning, to get the denominators to be the same. Any other questions on this method? Yes, Eric.
So you had on the last step there, 16 over 7 times 7 over 6x. Why isn't it just 7x?
Right.
Yeah.
So it was a fraction 7x over 6. This is the same thing as 7 over 6x. I just moved the x to the side. And then when I multiplied this by the reciprocal, all of this canceled. So just x was left.
So why did you put, okay, never mind.
Yes, okay.
Why didn't you multiply by only 6?
So I could have done that too. That's the longer way to do that. So I could have multiplied both sides by 6. Those would cancel, leaving 7x equals 42. Then you also would have had 2 divided by 7. But this process and this process are the same. It just one takes 2 steps and one takes 1. We're going to do the second method where we get rid of the fraction this time. So somewhere where you have space, write this problem again. Look at this backboard from method 1. Tell me where you got lost at.
In column.
So the very, very bottom. Then
Like 6 over 7 equals 7x over 7.
they're multiplying by the reciprocal there. So they combine like term, or we combine like terms to get 7x over 6, and then multiplied by the reciprocal, so that it's simplified. But if that way doesn't make sense, we're going to do a second way, and that one may make more sense. Okay, so for this one, because we're going to get rid of the fractions, we're going to multiply the entire side by something that would be a multiple of these two. So we're going to use 6 again. But because we're multiplying the entire side by 6, we also have to multiply the other side by 6. So here is where our multiplication property of equality comes into play. Yeah. Because 3 and 2 both go into 6, I need some number that would get rid of those two. And it has to be a multiple of both. So when we do this, we're going to kind of distribute this 6 across. So 6 times 2 would give us 12x, and this would just be over 3. 6 times x would give us 6x, and this would just be over 2, equals 42. Now right now, we still have fractions, but they're going to simplify. Because I can look at 12 divided by 3, well that's 4. 6 divided by 2 is 3. And now I no longer have fractions. Now I can combine my like terms and divide both sides by 7. So if that way seems easier to you, or you like that method better, that's perfectly fine. If you like the first way better, that's also fine. It's your preference, so when you get questions like this, you choose which one you like. Do we have any questions on that one? Where does 7 come from? This 7? We combine these like terms, we got 7. Really quickly, I'm going to go through and do the check on this. Handwriting is not good today. So I put 6 in for both of my x's. This would give me 12 over 3 and 6 over 2. 12 over 3 is 4. 6 over 2 is 3. 4 plus 3 is 7. So that works. We're going to do one more together, then I'm going to let you, for the remainder of class, try the others. So looking at 7, 8, and 9, of those 3, which would you like to do together? 9. So for number 9, we have parentheses. Let's deal with that first. We have a number outside of the parentheses, so distribute. I'm going to bring the 4m down. This would become negative 15m and negative 50. From there, we have like terms, we could combine them. Remember when we're combining like terms, we're doing whatever it says. So 4 minus 15 would give us negative 11m. Now that we've combined our like terms, this looks like a more simpler problem. So now we're trying to get m by itself. So we're going to get rid of 50 by adding it to the other side. And then dividing both sides by negative 11. What is m?
Negative 16.
This was actually the same one that second period picked, so I have this in my calculator already. So I put in negative 16 for all my x's, and I got 126, which is what the problem equals. So that works. Do we have any questions on number 9? So there are number 4, number 7, number 8, number 10. Yeah. 4 problems on this that I want you to work through. Talk with the people around you, ask questions. Do you want me to check something? Ask. If you finish that, I want you to move on to this page. See if you can figure that out. It gives an example and it kind of wants you to fill out the table using that example. So you can definitely try that. And then we'll go over it for sure next class. But do these 4 problems first. If you finish those and those, you can keep going to the word problems. But you may not have time to do all of that. I will be around if you have